Hello students, hello everyone. This is senior college mathematics. Topic of discussion in this series of teachings is surds, or you call it radical. Surds or radical. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external exams into high school, this topic, this lesson is for you. Lesson 1, rational and irrational numbers. Mathematics is made up of numbers. So two sets of such numbers are rational numbers, irrational numbers. So these two numbers form the basis of surds or radical. For updates, follow PetakusEduCom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like and share this video to your friends, your colleagues, your classmates. Facebook at fb.me/PetakusEduCom, Instagram at PetakusEC, Telegram t.me/PetakusEduCom, WhatsApp via this telephone mobile number or mobile telephone number. Okay, in all of these platforms you get updated from time to time about what is happening at PetakusEduCom community, where you have access to quality, unlimited and simplified mathematics teachings in series. Okay, so we start by looking at rational number. Listen carefully. A rational number is a number that may be expressed as a ratio of two integers. In ratio you can express them in fractional form. For instance, s ratio y, that is s dot y, can also be expressed as s divided by y. So rational number is a number that may be expressed as a ratio of two integers. The next keyword there is integers. Now, integer is a set of number that is positive or negative. Anyway, they are whole number. Positive or negative whole numbers including 0. So if I have 1 as a whole number in the numerator and I have 2 as a whole number in the denominator, what you have is a rational number. Okay, rational number, this is set for it, looks like Q. This is set, or the notation for rational number include number 1, all numbers of the form. So any number you can express in this form, that is P divided by Q, where P and Q are integers. Any number expressed as P over Q, where P and Q, they are whole numbers, negative or positive, we can refer to them as rational number. As you are doing that, you must know that Q cannot be 0 because you cannot divide any number by 0. The result is always undefined. So the first set of rational number is a set that looks like P divided by Q. Okay. Number 2, integers, which are whole numbers, may be positive or negative. I've said that before. For example, -3, -2, -1, 0, 1, 2, 3, and so on. They are integers denoted by this. These are look like Z. Okay, When it has power of positive, it means positive integer. Positive integers. When it has power of negative, it means negative integer. So any number in this form is also said to be a rational number. Number 3, you have proper fractions. Proper fractions, they are numbers less than 1. For example, number like 1/3, 2/3. Now look at this number, compare it to p/q. So you can see that now any number in proper fractions form is a rational number. Etc. These numbers are less than 1 because the numerator is always less than the denominator. Another set of rational numbers are improper fractions. These are numbers greater than 1. For example, 3/2, 4/3. 3/2, 4/3 also looks like p/q. So all improper fractions are rational numbers. Okay. Another set is mixed fractions. Mixed fractions are numbers like 1 whole number, 1/2, 2 whole number, 3/4. These are numbers formed from the addition or combination of a proper fraction and a whole number. Mixed fractions, they are fractions obtained by combining or adding a proper fraction and a whole number. And because of the fact that you can convert all mixed fractions to improper fractions. For example, if you look at 2 whole number, 3/4, to convert to improper fractions, you multiply 4 by 2, that is 8. You add it to 3, that is 11/4. So it is now an improper fraction. And because it is in the form of p/q, it is a rational number. So all numbers in the form of p and q, they are always fractional. That can be proper, improper, or mixed. So they are all rational numbers. Alright? You must know that powers and square roots may be rational numbers if their standard forms are rational number. When we discuss later, when we discuss indices, we will see standard form. Then we'll learn that they may be rational numbers as well. For the purpose of emphasis, in rational numbers, the denominator cannot be 0. You must note that. If it is 0, it means it's no longer a rational number. It will be undefined. For example, 2 divided by 0 is not possible. You can't divide 2 by nothing. So in rational number, the denominator cannot be 0. Are you following? Okay. The next set is irrational or non-rational number. This is the opposite of rational number. So irrational or non-rational number is a number that cannot be expressed as a ratio of 2 integers. That is, an irrational number cannot be expressed as a fraction. That is the meaning. While you can express rational numbers as a fraction, you cannot express irrational number as a fraction. As a matter of fact, the value of an irrational number is unending. You see why you cannot express them. They go on forever or continue till infinity. Examples of rational numbers are square root of 2. You have 1.4142, 1356, and so on. Now you may be wondering, but there's an F in calculator. It is not so. The calculator is only programmed to certain digit. If it is programmed to 9 digits, it will only give you the first 9 digits and ignore the other one. If you want to divide it manually using, you just keep on having numbers like that. So of course you cannot express this number as a fraction, so it is irrational number. Value of pi, as you know, is 3.14159.265 and so on. It is also an irrational number. Others include square root of 3, square root of 5, etc. So the square root of all non-perfect square are irrational numbers. Likewise, their multiple or their fractions. Yes, non-perfect square, they are numbers that you cannot get their square root easily, such as root 2, root 3, root 5, root 6, root 7, root 8, and so on. So this is rational and irrational numbers. The next thing we look at is definition of surds. Now that we understood rational and irrational number, the next thing is to define a surd. First definition is a number whose square root cannot be expressed as a fraction or quotient. Quotient means division in form of p and q, as we said earlier. Such numbers are referred to as surd. That is the first definition. Second one, a number whose square root is an irrational number. Just like the first one, you cannot express it as a fraction or quotient. Is also a surd. Note, rational numbers are numbers whose decimal repetition are neither terminating nor repeating. They continue like that. No, that means no ending, non terminating. They have no ending. Okay. The third definition: surds are irrational numbers written as the square root of numbers which are not perfect squares. So the square root of a non-perfect number or a non-perfect square, its square root is a surdic number. So we have these. If you look at all of them, they point to the fact that a surd is formed from irrational number. The first one, you cannot express it as a fraction or quotient of two integers. The second one, you cannot get the square root of an irrational number. The third one, irrational number is written as a square root of numbers which are not perfect square. So surds are basically formed from irrational numbers. Okay. The next thing we look at is rules of surds. Rules of surds. Okay. We have some rules to be considered. So we are taking our number as a. So we have root a. So the first rule is that root a plus root a equal to 2 root a. What this rule means is that two different surds, two the same surd can be added. That is the meaning. The second rule, square root of a plus minus square root of b. This means two things. It means root a plus root b and root a minus root b. Now look at the result. The result is root b plus minus root a. What it means is that different surds cannot be added and different surds cannot be subtracted. Okay. Now look at this. If you have square root of a plus minus b, the two numbers under the square root, is not equal to, what it means that you cannot split it. You cannot split two different surdic numbers that are added to different form like this. It cannot be splitted. The fourth rule is square root of AB. That is product now. AB, it can be splitted. That means different surds can be multiplied. That's the meaning of that rule. That is, you can multiply root 2 by root 3 and you have root 6, but you cannot add root 3 and root 2. You cannot also subtract root 2 and root 3. Root 5 is when two the same surds are multiplied, the square root sign disappear. You understand it better under the multiplication law of indices. So root A times root A is equal to A. Alright. The sixth rule is division of two surds. It can also be splitted. So square root of A over B also means root A divided by root B, provided A and B are positive. So the 6 rules above only hold when A and B are positive. When A and B are positive. When they are positive. Okay? Alright. So let's continue. Let's look at basic and single forms of surds. Basic and single forms of surd. Root S, you know, we're assuming S can be any number. S can be 2, 3, 4, but we assume it now. Root S is said to be in its basic form if S does not have a factor that is a perfect square. If S does not have a factor that is a perfect square, that is, root S will only be basic if root S cannot be further broken into two factors where one of them has an exact square root. For example, let's look at root 11. For example, root 11 has no other factor that is a perfect square. So root 11 is in its basic form. You cannot simplify it further than root 11. That's the meaning. Then root S is said to be in its single form if it can be further broken into two factors where one of the factors is a perfect square. For example, look at root 12. If you observe carefully, among the factors of 12, one of them is a perfect square, that is 4. So you can express 4 as a perfect square. For that reason, 12 is in single form. So all single forms can be expressed in basic form. Summary: in basic form, you cannot express the number further than the way it is. In single form, you can express the number further because one of the factor is a perfect square. It's a perfect square. Alright? Examples. Simplify the following by reducing them to their basic form. Square root of 50. You ask yourself, what is a factor of 50 that is a perfect square? That is 25. So you express 50 as square root of 25 times 2. That we are applying one of the rules now stated earlier. And product of surd can be splitted. So square root of 25 is 5 and square root of 2 cannot be determined because 2 is not a perfect number. So while root 50 is a single form, 5 root 2 is a basic form. 5 root 2 cannot be expressed further than the way it is. Okay? Take square root of 147. If you check very well, you are going to have 49 as a perfect square. Now you are not saying, voice of Petakus, how can I know the perfect square in that number? What you do is that you try to divide them with non-perfect number. For example, if you divide 50 by 2, you have 25. You see that? Now, if you divide 147 by 2, it is not possible. So you try 3. You divide 147 by 3, you have 49. And you should know that 49 is a perfect number. If 49 is not possible, you have to jump 4, because 4 is a perfect number. You try 5 in the next division. You try 6, 7, 8. When you get to 9, you jump 9, because 9 is a perfect number. Because in basic form, 1 after the break it down in single form, after the break it down, one of them will be perfect number, the other one is non-perfect number. So you have 49 and 3. If you break it down, you have it this form: square root of 49 is 7 root 3. Okay, so let's check another example. 490. If you carry on the division as I've said, you will have 49 times 10, where 49 is a perfect square that gives 7 times the square root of non-perfect square, 10. That is basic form. Example 4, 243. If you carry on the division using 2, 3, 5 like that, you have 81 times 3, where 81 is a perfect square and 3 is not. For 81, the square root is 9 times 3. So you try 5, 7, 8. If you divide by 2, you are going to have 289 times 7. 289 is a perfect square because its square root is 17. So you have 289 times root 2. When you do that, you have 17 root 2. 17 root 2. Okay, so after division, for example, now after dividing 5, 7, 8 by 2, and I have 289, if you are not sure whether 289 is a perfect square or not, you simply check the square root of 289 in your calculator. If it gives you a whole number, it means 289 is a perfect square. If it does not, you divide 5, 7, 8 by 3, the next number. Okay? So express each of the following as a basic surd, as a single surd, That is, you have the basic form, then reverse it back to single form. So the basic form is 3 root 11. So, and that means 3 times root 11. Now the question is, which number that its square root is 3? That number must be 9. You see the idea now? So you think of a number whose square root will give you the one outside the square root sign, 3. And that number is square root of 9, not just 9. So that when you reverse square root of 9, it gives you 3 in return. So you are writing 9, you are writing root 9, not ordinary 9. And because we've stated that 2 different surds can be multiplied, root 9 times root 11 is root 99. So this is a single surd. Number 7, the same thing. 10 root 6 is expressed as 10 times root 6. The perfect number or the perfect square whose square root is 10 is 100. How do I know that? 10 times 10 is 100. 3 times 3 is 9. So 10 times 10 is 100. To get that 10, it has to be square root of 100 times square root of 6, because two or more different surds can be multiplied. Root 100 times root 6 becomes root 600. Are you following? Okay, all right. So this is rational and irrational number, basic and single forms of surd. End of lesson 1. Thanks for watching and learning with PetakusEduCom community. Don't forget, watch out for more from the voice of Petakus. For questions and inquiry, use the comment section. For the complete package of this topic, lesson 1 to 6, for offline usage, you can contact the voice of Petakus via this WhatsApp number or through the email address. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you. That is the Lord Jesus Christ. If you are saved already, I tell you, be congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others. Use your hands and your brain to work genuinely, and the Lord will bless you. And goodbye for now.